Good evening, friends. Here I am going to discuss one of the numerical on maximum power transfer theorem. So this is Gaurav from Department of Electrical Engineering, Malodi College of Engineering and Technology, Nagpur. We are going to discuss this particular numerical which is displayed on the slide. So the statement where we have to find out the value of load impedance so that the transfer of maximum power can take place, and then we have to find out the maximum power transferred. This question was asked in summer 16 for 7 marks. This is the given network. So for this network we have to find out the above two values. Now please remember that the steps to find the value of ZL and hence P max is same as the steps of Thevenin's theorem. So you can check in the slide that step 1 is written to this particular circuit. So let us start. First, what I am going to do is let us mark the terminals, because this particular numerical is somewhat different. So let us mark the numerical terminals. So this is A, this is B, then I say this is C, and this one is D. Okay, so we have 4 terminals, and in between each two terminal there is element present. Okay, so now let us make a circuit to find the VTH. To find VTH, as we know, we have to remove or open circuit the load impedance and redraw the circuit. So now just check, this is A, B. At some distance I am making few more terminals. Okay, now this particular tilted elements where it is representing say Wheatstone bridge, right? So I just make all those 4 elements horizontal. This terminal is A, this terminal is B. 5 ohm and 7 ohm is present between A, C and C, B respectively. Okay, then between A and D you have inductor and DB as capacitor. So this is terminal D. Now in between A and D, so it means what we have this terminal as A, whose value is J10 ohms. Then between D and B, it means this terminal is B, a capacitor of J20 ohms is present. Now there is no element present, and we just stretched those tilted elements and we have represented in vertical branch. Okay, so therefore we have these two terminals as same, that is A, these two terminals as same as, that is B. Now again in between this terminal and the open circuit terminal of load impedance there is no element present, so I just extend this line up to this terminal and I can call this terminal as A. Similarly I can call this terminal as B. So this open circuit terminal where ZL is opened is representing Thevenin's voltage, or this can also be written as voltage between A and B. Now as we know the rules, we can call A as positive, B as negative. Then there is a voltage source present, right? So I just shift this C here. Here there is a voltage source present whose positive on the left hand side, and the value is 100 volt present between C and D. That voltage source is present between C and D. Okay, now after getting this, we get that there are 3 loops. This is loop 1, this is loop 2, and I just call this as loop 3 because we have to find the VTH between A and B terminal. If this is positive, I can say that current is, or loop current for this loop 3 is starting from this terminal, follows J10 inductor minus J20 capacitor, and then back to negative terminal. I just extend that line up to positive terminal. So this is my loop 3 current, but this is just a orientation of loop current. Here we don't get the flow of current as these two terminals are open circuit. Please remember. Okay. So now let us write the equation for loop equation, that is mesh analysis, and mesh analysis where you have to apply Kirchhoff's voltage law. So you can check the equations by using KVL in loop 3. In loop 3 there are three elements present. One is VTH, another J10, and third minus J20. So VTH, for negative to positive element it is positive, so it is written with a positive terminal, positive sign. Then J10 is from positive to negative, it means negative, so therefore it is written as minus I1 into J10. So this represents voltage drop, right? This represents voltage drop. Okay. Then DB, where we have J minus J20, so again minus I2 into minus J20, that gives me equal to 0. That is equation 1. Okay. Now in this equation three elements are unknown, but ultimately we have to find VTH, for which I1 and I2 to be known. Now to get this I1 and I2, I am applying KVL in loop 1. As I said, this is my loop 1, so I just call this loop current starting from positive of the 100 volt, ends at negative terminal, and the current represented as I1. I just follow same orientation for the second loop. If you follow reverse orientation, anti-clockwise orientation, there is no problem, you will get the same value. So I am just following the orientation of I1 and I2 to be same. Now I2 starts from positive, and it is from positive to negative for voltage source, and then follows capacitor and then the resistance, right? So loop 1 I1, loop 2 I2. As we have to find out the current through J10 ohm, that is say I1, and current passing through minus J20 ohms, that is say I2. So I1 and I2. So for which we have to write the loop equation, that is mesh analysis to loop 1, mesh analysis to loop 2. So again by using KVL in loop 1, what I get is negative to positive is 100. Here this is positive, the other one is negative. So positive to negative is negative. Then here again positive, here it is negative. So positive to negative is negative. So what I am getting is 100 minus I1 into 5 minus I1 into J10, right? Same method, same methodology. It is equal to 0. That is equation 2. Now I can write the value for I1. So I1 is equal to directly 100 upon 5 plus J10. Now it is equal to, so the value of I1 which I am calculating is 8.94. Okay, you can do the calculation in the calculator, minus 63.43 amperes. Current in amperes. Now KVL to loop 2 means this second loop. The orientation is same as I1. The only thing is for voltage source 100 volt, it is from positive to negative. So therefore it is represented with minus sign, minus 100. For capacitor it is from this end to this end. Let us say it is positive to negative. So therefore what I am getting is, first I am writing for 7 ohms, then say this is positive, the other one is negative. So positive to negative is negative. So I am getting minus I2 into 7. This is minus I2 into, the value of capacitor is minus J20. So therefore it is written in bracket. It is equal to 0. Now take this particular part on the right hand side, you get the value for I2. Directly I am writing it as I2 is equal to minus 100 upon 7 minus J20. Now this is equal to, right? So it is equal to 4.72 angle of, right? Just give me a second. This is minus 100 upon 7 minus 2i is equal to, so So 4.72 minus 109.3, again in amperes. So we got the values for I1 and I2, right? Now by referring equation 1, where we have to find VTH, so it is equal to, now we are getting I1 value 8.94, right, minus 63.43 into J10 minus 4.72 angle minus 109.3, right, into J20. Okay, so implies I get the value for VTH. You can write the value of VTH either in rectangular form or you can write it in polar form. So 8.94 angle minus 63.43 multiplied by 10J, right, minus 4.72 angle minus 109.3 into 20I. So this gives me answer as, you can write it as value of VTH 71.8 angle 97.32 in volts. So this is the value of Thevenin's voltage. Now step 2, here you have to find out the value of ZTH. Here you have to find out the value of ZTH. Here what I did is I am just copied the same circuit, right? But while calculating ZTH, as you know, all the energy sources to be deactivated. In this circuit there is only one voltage source. To deactivate that voltage source, you have to put a short circuit. As soon as you put this short circuit, you find out that C is equal to D, or you can say D is equal to C. It means this particular point is same, right? So equal to D or D equal to C. This particular point is already A. This part or point is already B. It means what? This 7 ohms minus J20 is connected in parallel. This 5 ohm and J10 is connected in parallel. So what I can write is directly, please check, ZTH is equal to 5 parallel J10, right? Then you get the series circuit, because this is the common point connecting this branch and this branch. So you get here, just trace the pain. You find that the series connection as pain path is same. So 5 parallel J10 plus 7 parallel minus J20. So here the value of ZTH is equal to, right, here you have to write down in only one form, that is rectangular form, then minus J 0.1826. So this is the value of ZTH. Now therefore ZL is equal to, right, ZL is equal to complex conjugate of ZTH, right? This is our formula. We have to find out ZL. So step 3 to find ZL and Pmax, it is equal to, now complex conjugate of this is 2.36, right? Complex conjugate, so that minus becomes plus 0.1826, where if I just compare 10.236 is load resistance whose value is, right, put it in the Pmax value, where VTH is 71.8. So 71.8 angle 97.32, right, whole square divided by 4 into 10.236. This gives me value of 125.63 watts. So that's all. Thank you very much. Have a nice day.